Good morning, and welcome to the O-Scope Wizard. It is Baby Friday. We are rocking and rolling on this Friday. Oh, am I a little loud? It looks like I might be a little loud. Let me turn it down just a little bit, so hopefully I'm not blowing your eardrums out. Yeah, Baby Friday. Second best day of the week. The anticipation of actual Friday is what makes Baby Friday so awesome. And I'm encouraging people to make it the soft close of the week. We were discussing in the chat just now how actual Friday is being, it's almost being ruined by conference callers. This sudden need for everyone to constantly be on a conference call or a video call. And for some reason, Friday afternoon seems to be the time when people realize that they have some makeup work to do and they better show their face. So they try to schedule all these conference calls on Friday afternoon, unappreciated by the rest of us who don't want to do that. The topic of the stream today, I might have done some clickbaity because I was going to talk about my new pot, my new potentiometer, but I've managed to burn all of my pots. There is innuendo there. I apologize kind of for it. But my soldering skills, I have all these potentiometers soldered down to these packages, and I talked about it in the last episode, and I have burned them because my soldering iron was set to maximum. I basically treated the temperature gauge as a volume knob and just ripped it off at 12, at 11, not 10, 11. There's a reference to Spinal Tap there. Anyway, that's okay. We're gonna do a bunch of other stuff. Let's see. Somebody's asking, what if I combined a circuit using pot in a? Okay. I get you. I'm gonna have to beep all kinds of stuff out, but I do love it. We're a little looser on Baby Friday. I don't know what it is. Something about it really is that anticipation of the weekend that just keeps me a little bit loose. It is really weird because it feels like you could bring the same level of energy every day, but you can't. There's always a limit. I have my good and plenties. Hopefully you have something exciting. I have coffee. I also have hipster water, lemon today, so I'm rife with options. In fact, I was thinking about this before the show and I had to Google it. Rife, R-I-F-E, with options, or ripe with options, R-I-P-E, as in ripe fruit. But when I Googled it, it is actually rife. It is rife. Rife means plenty, an overwhelming amount of. I did know the phrase, but sometimes, when you hear a phrase over and over again and some people say it one way, ripe with opportunity or rife with opportunity, it's hard to tell which is the correct phrase. It is rife, though, R-I-F-E. And then that took me down another path about just desserts. It is just desserts, that is how you say it, but it is spelled D-E-S-E-R-T-S, like deserts, but you pronounce it desserts. And apparently it is from an older noun than desserts, like the end of a meal, D-E-S-S-E-R-T. Anyway, the O-Scope Wizard, not the grammar wizard, so I digressed quite a bit there. Yeah, Baby Friday. It's weird. It's weird up in here. But we are going to get back to the DIY Sonos style Raspberry Pi right after I start my timer, because we're going to make some measurements today, just like we did on Tuesday. Let's start it and get into it. Get into my measurements. Well, I can't really see what it says here. It should say, there it goes. Does it matter how you plug it in? Does it matter how you plug it in? That's my question. One thing that I've been doing with the Raspberry Pi is powering it through the GPIO header. And I wondered if it made a difference. Two things. Does it make a difference on the noise of the DC to DC converter if I plug it in through the USB port instead of using the GPIO port? I was wondering if on the USB port there might be better power supply decoupling. So maybe the noise from the Raspberry Pi doesn't get back out to the DC to DC converter if I use the USB port. So we're going to make some measurements there. Also, you'll see that the box is a bit empty today. I've pulled everything out of it because I wanted to do the layout differently now that I'm not using those giant DC to DC converters. And if the last question is, how much current is my Raspberry Pi and my LED ring? This is the thing I was most concerned about. How much current is my NeoPixel ring and my Raspberry Pi going to use combined, because they are both running off of 5 volts, so I want them to run off the same DC to DC converter. And I wondered if I could use this tiny guy. I really just, this tiny guy, for $1.59, I am fascinated by both its size and its layout, really. It's so little and compact. Does it supply enough current? I'm gonna find that out. So first things first, we need to plug it in, turn it on. You can see I have a board here. This is a pretty handy board. You can get them off of eBay. I've mentioned them before, but it fans out the USB connectors to headers. And I am most excited about the V-bus and the ground because I can plug that directly into my DC to DC converter. And make some measurements. So I suppose I should plug in my oscilloscope. I'm using my Power Rail probe, again, just like we did in the last episode. Out negative, that is going to be ground. Out positive will be my power. And let's plug this in through the USB connector into the Raspberry Pi and see if it has as much noise going that direction as it does plugging it directly into the GPIO. So I suppose we'll do, you know what? Let's do GPIO first, and then we'll come back and do through the USB port, and then we'll measure the current, and then we'll try the little guy, the itty bitty guy that I have. So that, we got a plan of action. Hopefully everybody's still following along. The chat thinks there's going to be less noise if I go through the USB port. I think that too. That is true. I'm making that guess. What do you call a guess? A theory. Trying to teach kids science. Can't call it a guess, you call it a theory. My theory is going through the USB port will be less noise on my Power Rail, but let's turn it in, or plug it in. I'm always nervous when I first plug it in and turn it on because I'm nervous that I am going to blow it up. I can't help it. I'm still nervous that I'm going to blow it up. Okay, it's turned on, it's plugged in. I need to log into it. So let's go check out my desktop real quick. Log into this thing. Okay. That's a little disconcerting since I've logged into this thing about 8 times. 8 times? I've logged into it about 800 times probably. Let's crank up my little Sonos amp interface that I have running. All right. Okay, mostly I just want, if I go back to my setup here, I just want to make sure that my lights are turning on because eventually we want to measure the current for everything. Okay, so we can see that the lights are working perfect. Awesome, got all the lights going, beautiful. Unfortunately, you can't see that that's pink. That is pink. Now let's make the measurement on my oscilloscope. That didn't work at all. Turn on the scope. There we go. First things first, preset the scope. I don't have private keys set up. I don't have private keys set up. Guys, when I do these things, I don't know what I'm doing. I'm just like starting it and going and learning a lot along the way. I don't even know how to set up private keys. I don't know anything about that. I suppose that I would need to Google that. It feels like a thing that I should Google later. I remember maybe reading about that, and that is a good point from the chat, from James in the chat. I probably should explore that a little bit more. Let's grab a little bit more time. Let's grab a millisecond. Okay, that's a lot of noise, right? That's a lot of noise. So that is plugged directly into the Raspberry Pi. Tons of noise. Let's, instead of just saying tons of noise, let's go to peak and check out waveform 1. And we can see that it's, yeah, lots of it. Lots of it. Turn on statistics. Turn on statistics. There we go. Okay, 276 millivolts of noise. Not a lot's happening. If I did send, let's just see if it changes if I sent music to it. Not that I don't have the speakers plugged in, but I would still be making the connection. And that would add noise. So now I'm connected through AirPlay, and I'll just play something. Did the noise change much? No, it did not. Okay, well that's a good sign. That is a good sign. I was a little worried that it would like go completely crazy. Oh, well that's nice. James in the chat is offering to show me how to add the keys so I don't have to enter a password. That is actually, that's going to be super useful. I'm like thinking through that. Oh my goodness, what a noob. I'm glad I showed that because I would have never even known to ask that. That is one of the struggles that I have is I don't even know the questions to ask. Okay, so we were at max at 310 millivolts when connected directly to the GPIO headers. Let's turn it off, and connect through, well, let's see if we can make this work. There we go. Turn it off. There we go. Takes a little while to turn off. This beastly 24 volt power supply has some big old capacitors in there, so be careful when you're messing with the big caps. You don't know how long they're going to stay charged up. I'm not going to touch them. But I am going to connect through the USB port of my Raspberry Pi now. So where were we? 310 before? I believe. So I need to plug power into V-bus. So positive to V-bus. And then negative to ground. Keeping my measurement point the same on my board. Still using my sticky putty to hold everything down. I do love, if you guys don't have this non-conductive sticky putty, I don't even know where to buy it. I get it with probes as an accessory, and I get a lot of probes, and I use it all the time. I love it. Okay, so we're back. We're back in action. Let's go back over to the oscilloscope. There we go, the oscilloscope. Oh man, somebody in chat. Randy in chat is saying he used to charge up big caps and leave them out for his classmates to discover that. That's cruel. That is cruel. I'm glad I didn't go to school with Randy because I would have been shocked. Ho, 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 ho. I heard it. I heard it. I did. I heard it. Yep, that's true. Corny, making puns on a baby Friday. Okay, I would say that the noise going through the USB is about the same as, I guess, let me enable my, my software, because before I was using my interface and the software was running, which presumably will affect the noise level. All right, so my software is running. And ta-da! About the same, right? Oh, it was 310. We're occasionally jumping up to 300 here if I let it go for a little while. Yeah, I don't think going through the USB port actually makes it quieter. So our theory, my theory, I won't put this theory on you guys. My theory is wrong. It doesn't matter how you power the Raspberry Pi, if you go through the USB port or straight to the GPIO, it's just noisy. It is just a noisy mess. I mean, the percentage of noise is quite high. My power rail here is 5 volts. My max noise here is 300 millivolts. That is not quite 10%, but heading that way. Heading that way. It is a noisy thing, this Raspberry Pi. If it was it would be the toddler of computers when it comes to noise. I'm not even going to do the dad joke because that was too corny for even a dad joke, but you should laugh. You should laugh. Enjoy the jokes. Okay, so that's that theory proved wrong. Now let's move over to how much current am I using? So right now you'll see that my lights are completely turned on. So that, and the Raspberry Pi is running, and I can send music to it to see if that affects the current draw as well. Since the Raspberry Pi is not directly powering the speakers, its whole job is to aggregate the sound source coming in and then send that sound out to my digital analog converter, which is a separate chip entirely going to be running off of a separate power supply, clearly, since the noise of the Raspberry power supply is loud. Oh, James is saying that there is a protection diode from the USB port. So there might be benefits beyond just noise going through the USB port. There is some circuitry right here on the USB port, and that is one of the reasons why I kind of want to use it, because I feel like the designers of the Raspberry Pi are telling you to use it, and if they've engineered it to power their board, maybe I shouldn't think that I'm smarter than them. So I probably will ultimately use this port to power my Raspberry Pi, and I just will get a little adapter that goes from a USB micro male jack and solder it over to this DC to DC converter, or a DC to DC converter. But let's see. One of the questions is, could the lead inductance of the probes cause the high noise levels? Now, they will pick up some noise, but if let's do a real quick test. If I just disconnect the power from the Raspberry Pi and then look at the noise, so we'll go back over to the scope, turn on the scope. This is with the Raspberry Pi plugged in. And this is with the Raspberry Pi not plugged in. So you can see that the Raspberry Pi is the culprit for most of the noise. So this is the same power supply. The Raspberry Pi is not plugged in. It's 50 millivolts. So, that Raspberry Pi, loud. Let's see. Plug in your USB breakout and use a digital multimeter to test the VBus 5-volt node and the 5-volt pin on the GPIO header. Oh, to find out if there is a diode there. Is that what I would be testing? You're going to have to walk me through that. But I can do that, I think. I have a multimeter right here. It's all plugged in and ready to roll. Right now I was going to use it. I was going to use it to measure the current, but I could use it to check out diode connections, I think. There's a question in the chat about that noise. So when the Raspberry Pi was plugged in, it was 300 millivolts of noise. When it was unplugged, it was 51 millivolts of noise. I have the measurements from the other day. This is the XL4015. I kept saying 405. When it was loaded, it should have been 35 millivolts of noise. Of course, we were limiting this to 500 kilohertz of bandwidth at the time because that is what we cared about, because that is close to audio. So if I did limit it, it would drop down to 35 millivolts when loaded. Unloaded, it was 30 millivolts. This little guy, this XL4015, is the quietest of the bunch, and that is the one that we were using. But I wanted to use the even smaller one just for space constraints. So, oh, okay. Yeah, that lab notebook. It turns out this notebook is Miss Oscope Wizard's notebook from, she tells me, from high school. When she saw me using it, she was like, "What are you using my high school notebook for?" There was plenty of pages left, and it is, you know, got gridded paper. I do love gridded paper. Grid paper with a grid on it. Gridded. Okay. Let's just do some testing here. Okay, V-bus. We'll just do a real quick resistance test of V-bus from the USB port to the Raspberry Pi GPIO port. What do we got? 1 ohm. I'd say it's pretty low resistance. That feels like a direct connection. I mean, if I just plug these leads, I'm not using a 4-wire resistance measurement because I only have 2 wires plugged in. But if I just plug the wires directly, you can see that it's 1.3 ohms. And then if I plug V-bus directly into my GPIO V-bus, it's about 1.3. So yeah, I think it's, I don't know if there is any diode protection. Let's see. Oh, there was questions in the chat to ask about peak noise versus broadband noise. Now we can check out the noise signature of this guy, of this power supply, but let me measure the current first since I have my multimeter out. So maybe I'm overthinking this USB input on this Raspberry Pi. Maybe I just want to use it? I don't know. There seems to be absolutely no benefit or reason to use it over just tying my power directly to the GPIO. If I tied it directly to the GPIO, my wiring would be smaller. And that's how I have been doing it. I had been tying it directly to the GPIO, and it was working fine. No big complaints. Okay, well, let's get to the current measurement. So to do a current measurement, I need to plug in series with my power supply, meaning I want the current to flow through this wire into my multimeter and out the black wire back to V-bus. Okay, so plug this in, plug my ground to ground. So always want to make sure that I plug ground to ground, because you know a good way to end a Raspberry Pi's life is bypass or plug power into ground. There we go. Whoa, oh my goodness, I was still live. Well, that was lucky. Let's make the current measurement, guys. DC, holy moly. 5 minutes remaining. Okay, 5 minutes remaining. That's good. That's actually a good time because we're deep into it. You can see the current. Let's see what I'm measuring. Let's point it so we can look at it well. I think Let's get a good angle so you can actually see it. You guys see that? 300 milliamps. My lights are not illuminated. So let's illuminate the lights. That means I got to start my software back up. Let's start my software back up, type in my password again like a total noob. Oh my goodness. Software is started. The lights are fully illuminated. 300 milliamps. I mean, goodness gracious, that is really efficient. Really efficient. 300 milliamps. Okay, so you can see lights are all on. We got lights, camera, action. If I turn the lights off, I do like, man, I love blinking lights. There needs to be more blinking lights in our lives. 300 milliamps. Hardly any, I would say that is very efficient. The Raspberry Pi is doing good work there. Well, one last thing. What if I send sound to it? Does that change the amount of current used? So let's send sound to it. Sound is going to it now. Still 300. Oh, sometimes 350 milliamps. Yeah, that is that's great. I was worried about using this little guy right here because its current capacity is only 3 amps, whereas the bigger one, the bigger DC to DC converter can do, I think, 5 amps, so it is higher power. But if I'm only drawing 300 milliamps, goodness gracious, that's hardly anything at all. One last question while I'm here, while I have it all plugged in and illuminated and going at maximum volume. Actually, no volume is coming out right now. Let's check out the last thing. The broadband noise. Is this broadband noise or not? So this is, again, the power supply powering the Raspberry Pi. Right now, I'm going through the USB port, but that doesn't seem to make a hill of beans of difference. If I do that let's do an FFT of this channel. I want my stop frequency to be pretty low. So let's make this 1 megahertz and channel 1, because I'm mostly concerned with super low frequencies. 1 megahertz. So if a resolution bandwidth is 1.5 megahertz, it's going to be a little hard to see in megahertz. So let's turn this down to 100 hertz. All right. Another thing that I could do, since I am only concerned about this low frequency stuff, I can, well, dude. Can we just, I'm going to use my knob real quick on my scope because it's easier for me. Bring this up. There we go. There we go. And I probably don't need quite so much data, or quite so much samples. I don't need 10 gigasamples of data to look at 1 megahertz of bandwidth. You don't need that much. Okay, so this is the noise on this DC to DC converter. There are some spikes in here. Where are we at? 100 hertz per division, so 100, 200, 300, 400, 500, 600, 700, 800, 900 megahertz. 100 kilohertz per division. So this is just below 200 kilohertz, the biggest spike down here. I think that is actually the switching frequency of my switch mode power supply. I do track waveform, move it down here. Let's see where this peak is. Where are we at? 190 kilohertz. 190 kilohertz. But it's a lot of noise. Oh, can I disconnect it and see the noise without the Raspberry Pi? Sure, yeah, let's do that. Let's see it before and after. Gotta see it before and after. So this is connected, this is disconnected. Whoop! You can see my noise drops precipitously when I disconnect the Raspberry Pi. Oh, and you can also see the power supply kind of struggling around here, unloaded. It's just like, what am I doing with my life? Why am I here? I'm just bouncing around. And then we'll reconnect the Raspberry Pi. And boom. There we go. Locks in. Oh, there is still some noise down there, isn't there? The power supply kind of gets its life right. Actually, there it goes. Occasionally popping up. I don't know, it's out of the audible band, which is good. I'm mostly concerned with things that are in the audible band, so way down here, and that looks pretty good. Noise on a Raspberry Pi, man. Raspberry Pis are just noisy as all get out. And whoa, somebody's asking for a total harmonic distortion measurement. I don't even know how to make that measurement. I don't. The noise floor does not go up when you plug in the Raspberry Pi. Just peaks show up everywhere. That is true. That is what is happening. The noise floor itself, this down here at the bottom, it stays pretty consistent, but the peaks just go bananas. Okay. Somebody is saying that the Pi's switcher to get from 5 volts to 3.3 volts might run at 170 kilohertz. That could be something that I could Google. The total harmonic distortion is built right into the scope. I'm getting schooled on the scope. Let's see. Last thing. Let's see if we can make a total harmonic distortion measurement, and if I even know what that is. Let's see. Total harmonic distortion. Right here. On. Now there it is. THD. I got a bunch of different options. Turn it on. Minus 21. I probably need to do some setup. So let's do some measurement setup. I'm gonna be totally lost on this one, guys. Over my head. I'm over my head. Let's do the setup here. Let's change my threshold. Probably to something that makes sense. There we go. You can see the measurement threshold. Let me turn off the cursors because they're kind of getting in the way. See the measurement threshold moving up and down. Let's make the measurement threshold above my noise floor so it hits the peaks. And yeah, let's maybe turn down my excursion so it picks them up a little bit better. 3 dB. Yeah. Turn on some statistics. Let's just, you know what? Let's add more total harmonic distortion measurements. Let's just do all of them. All of them. We just got so many of them. Oh, this looks like one of those audio data sheets that is, that's something that I see like on speakers that I don't really know how to read, but you're just like, oh, yeah. 4% of, you know, the omelet was much better. Let's move this down, my threshold. Let me go back. Threshold. Boop, boop, boop. Measurement group. Turn this down. I'm doing the wrong way. There. Wondering why it's saying, why is it saying question mark on the measurement? Huh. I'm not sure on that one. Let's add harmonic search too. We can just add all of them. Okay, so I can see some. Let's pause it for a second. Let the scope get its mind right. I have a table of all kinds of frequencies that it's. So these are all the peaks that the oscilloscope is catching. It's got one at 91 hertz and 183 hertz, and then we start getting up into the kilohertz range. I think I want to change. Let's see if I go to harmonic search. Yeah, I think I can change my threshold so it's a little higher. So we actually try to catch these peaks that are out a little higher. Yeah, there we go. I have a bunch of them out at 180 kilohertz, which is kind of this spike right here. So yeah, the total harmonics distortion, not terrible. Less than 1%. That's pretty solid. Also, again, this power supply is not going to be powering the audio portion of my circuit because as soon as that Raspberry Pi is plugged into the digital analog converter and allowed out into the speakers, there is a hiss. There is a hiss. You can't get rid of it. That's why I'm having to use a separate DC to DC converter for the Raspberry Pi. I was just curious whether I could get away with using this teeny tiny one. And I think I can because it's only using 300 milliamps of current. And that was the longest 5 minutes ever. But we did make some measurements. We checked out a lot more than I thought we were going to check out. We checked out the noise, both directly into the GPIO and through the USB port. There seems to be no difference in noise, no matter how you connect. So I guess it doesn't matter how you plug it in. You can plug it in however you want. We also checked out the current draw, which was only 300 milliamps, with the Raspberry Pi rocking and rolling and all my LEDs turned on. And then we got a little bit esoteric and started doing some total harmonic distortion measurements. And the power supply seems to be great at that. It's actually less than 1% of total harmonic distortion. And there are some suggestions that I get flux capacitors. I agree. We should get flux capacitors and all go 88 miles per hour. I noticed my kids don't even understand that reference at all. Our kids are going to forget that movie. That movie also, having rewatched it, they didn't age great. They didn't age great. But still probably worth a quick look. Well, thanks for hanging out with me on this awesome Baby Friday. I'm going to hang out in the chat after the show. I don't know all the nerds in the world, but I would love to meet them. So please share this with a nerd in your life. And I will see you guys next week when I actually plug stuff back into the amplifier and we get the sound fired back up. And maybe next week, I actually have my new potentiometer soldered onto a board and working. I'll see you guys later. Take it easy. Bye.